Assalamu alaikum. In this session, I'm going to talk about event-driven architecture. Whenever we think about any architecture for system development, there always some question will come into our mind. What is event-driven architecture and what does it mean to be and why we implement that? So let's start to understand what does it mean to be event driven. So it is important to note that an event is simply an actions. Means events are actions. Whenever something happens, an event has occurred. Let's suppose you need to use an application, and for that first you need to sign up, and for sign up you need to perform some action. And during sign up, if user provide valid data, then user successfully created, and you will notify user through email or SMS. It's depend on the business. So now comes into second question: what is event driven architecture? So event driven architecture is often referred to as asynchronous communication. This means that the sender and recipient don't have to wait for each other to move on their next task. So, have you've seen in that picture, we have a producer and we have a consumer. But in that middle, we have a message broker. It's your choice which message broker you want to use. We have an option, let's suppose Kafka, we have a RabbitMQ, we have IBM MQ. Okay, so based on your architecture, which message broker you want to use, you can use it. But in that example and in that session, I'm using Kafka message broker. So we can say that event driven architecture always follow producer or consumer concept which you have seen into that picture. Why use event driven architecture? Event driven architecture due to unique characteristic and consideration of a synchronous system. This style can offer important benefit for complex application. Build and deploy application independently in loosely coupled applications. If you see in that diagram, we have a user service, we have a SMS service, we have an email service, and that architecture suits for my example and is based on my need. I created that diagram. So whatever your business and whatever your need, you will implement a synchronous system if it suits your requirements. So let's say I have an user service and it's a producer, and I have an SMS and email service. They both are consumers. So producer will going to be produce a message and the consumer will going to be consume their messages. So it doesn't mean we have 1, 2, 3, 4 and 5. We have one too many consumers we have. Let's say we can say that we have one producer and one producer have many consumers. So if I want to downgrade or upgrade email service, so I can independently do. Okay, let's say, as I mentioned, build new features using events without changing existing applications. So if I want to change something in ML service, so I don't need to be downgrade the all application system. So if I want to upgrade the SMS service, so I need to be upgrade that specific service, no need to be upgrade like email or service. So based on the service, I will go and directly upgrade that services. So let's see the example how it's going to be works. So I have created that example how our application will communicate with each other independently. So as an example, I show diagram. In that diagram, user is a producer and SMS and email is a consumer. Okay. So I have created a sign up API and there is our collection request. In that request, I'm going to be create user. So user successfully created. So see the user SMS sent. So event is triggered means we are producing message and that both service are consuming that messages. Say going to be email. See it's consuming user email sent. Okay. So let's say if both are going to be downgrade and producer is up, so what will happen? It will going to be impact our business? No. What will happen? Let's see. Request successfully created. This means, see, we are producing an event. So now whenever our consumer is joined, so directly it will going to be listen that message. So see, consume that message which we produce when our service is down. So once it's up, so it will going to be listening that. Now it's time to explore code, how it's gonna be implemented. See, I have a user service which is a producer. Okay, so here is the configurations. I did Kafka producer configuration and that is a Kafka properties. So I'm creating a bean, okay, and this Kafka template, and I'm providing my things how my message is going to be consumed, what was the key and what was the value. Okay, and here as I'm using the default properties and here I'm overriding that properties. Okay, and in that producer project I have created a topic configuration and on the runtime I'm creating a topic. Okay, and the rest of the other part I have a service package. In that service package I'm just triggering an event. Okay, so who is calling that service? Here is we have a controller. In that controller I'm just creating an event. Okay, whenever request will come, user successfully created, so send an event from here. Okay, so this is the simplest code of for the consumer, sorry, producer. Now it's time for consumer. In SMS or email both are the same because both are consumers. So let's see their configuration. Kafka, same thing as the producer, but the thing is changed. We have a consumer factory. In that consumer factory, what I am doing, I am getting the default properties and I'm defining my business, how I'm going to be consume a key and value pair, how I'm getting the data. Okay, so here I'm defining a group ID, it's related to Kafka. Okay, and here's I'm defining my package. Okay, it's a trusted package or not. So here just a single class and who is a listener, and based on the I provide based on their group ID and topic on the annotation I defined. So whenever I'm going to be initiate, sorry, whenever I'm going to be create a message, so it will going to be Kafka. A Kafka have a topic and that topic will going to be consumed by consumer. So this is the simplest implementation. Now move to conclusion part. The what is why we use asynchronous and when we use synchronous system. Now for asynchronous and synchronous, we need to understand what is the difference between event driven and the REST API. So here is some points. I will read it. So let's say an event driven system is characterized by a producer or consumer model, whereas REST is request or response. Okay, as I mentioned, event driven system is asynchronous or REST APIs is synchronous. So an event driven system tends to take a fire and forget approach to sending information downstream or to other microservices. Our REST APIs wait for a response from other service before making a decision. Let's say user want to log in and you need to verify credentials where from the other API or for the other service. So you should need to be wait. Okay, so here will not suit a synchronous system. There should be synchronized system. Okay, event driven systems tend to be more resilient to failure and can be more independently scaled. As I shown in that example in the practical demo, when my server is going to be down, it will not going to be impact in our services. Every service works independently. So we can say that in the end, event driven solution is better for asynchronous activity, whereas a REST based solution is better for the situation where client needs to wait for a response, such as authentication. And for the reference for the Kafka, I shared that some links so you can get the more knowledge about the Kafka topics and groups. Thank you so much for your time.